and our colleague, sorry, and our colleagues and special our community of practice guest on the behalf of Asia Pacific Association of Agriculture Research Institution. I'm honored to welcome to you this important session, which is Community of Practice on Food Loss and Waste. I'm Deepika Trivedi, your host for today's session. We are grateful to have your presence as we gather virtually to share knowledge and discussion strategies and strengthen our cooperations in our shared missions to how do we can reduce the food loss in the waste in the Asia Pacific region. Welcome to our third session of the APARI Community of Practice on Food Loss and Waste. Before we begin start this session, I would like to briefly reflect on the our success to previous session. Sorry, which is focused on urgent and often overlooked issues. The first session was the silent, I'm sorry for that, the silent famine, Asia Pacific hidden emergency of food loss and waste, which is session that brought much needed attention to alarming level of food loss and waste across the region and often occurring unnoticed yet carrying severe implications, which is food security, nutrition, environmental, and the livelihood. And we were privileged to have Dr. Ravi Khetrapal as the Executive Director of APARI as a keynote speaker. His insight and powerful slogan, which is Flaw in the Flaw, struck in deep chord, and participants reminding us that flaw, food loss, and how we can reduce. So, flaw means fail to manage, and waste and loss. And especially, we have to focus on that part. And now, our second session, the new strategies on handling waste in animal agriculture system for controlling GHG emissions. And we were privileged also. He has like Professor Pramod Pandey. He is a specialist on Department of Pollutions, Health and Reproduction, which is School of Veterinary Medicine, University of California in Davis. Now, we explored innovative strategies on animal handling agriculture waste as a strong emphasized policy framework, which is scientific and practical model for mitigation of greenhouse gas emissions. So, today's third session will directly on momentum, delving into one of the most impactful contribution, which is FLAW, to technologies because we need technology solution for manage to for food loss and waste, which is very critical ensuring sustainable food system in the region. And it is my pleasure to invite Dr. Ravi Khetrapal, Executive Director of APARI, to share his welcome and opening remark. Dr. Ravi, please over to you, sir.
Thank you,
Thank
Deepika. Welcome everyone once again on this newly launched platform of food loss and wastage as a community of practice. Deepika has given a good background of who we are, what we want to do, and what we will be doing in this COP, community of practice. Well, friends, first of all, my great thanks to all of you for joining. And I would like, after the presentations and all, or maybe later on, I would like to receive comments from you all how we can improve our community of practice. This is very crucial. It should not be only confined to a webinar, which we are doing now. There has to be some follow-up and some things coming up in terms of partnership building, in terms of knowledge exchange, in terms of collaboration and all. So I would like to seek your opinion also after we have all the presentations and discussion. So now let me have the pleasure of introducing our keynote speaker. We have one keynote speaker and one panelist. Both are very well known in their subject. They have contributed a lot. And I will start with Professor A.K. Dixit, who is a keynote speaker on the topic of management of food waste, technological options. You all know we have talked a lot about the importance of food loss and waste, and we have seen how this is leading to increasing hunger and poverty as a silent famine which it is bringing, how much serious it is in the region, in our region, in Asia and the Pacific. And today's talk is mainly on the solutions the technological options of the waste management from an expert, Dr. A.K. Dixit, rather I will say Professor A.K. Dixit. He is a professor of environmental science and engineering department at Indian Institute of Technology at Mumbai in India. And he brings 30 years of rich experience of teaching, research, and consultancy across many countries. I would say it is not only in India, but also in Bhutan, USA, Rwanda, South Africa, Sweden, Singapore, and in AIT, Thailand, and also Singapore. So he has been like a rock star, in terms of waste management, in terms of the technological options for that. And if you look at his background, he has more than uh, 200 international national research papers, and more so, 20 prototypes and equipments and 10 software applications which he has developed. He guided a large number of PhD and MTech and BTech students, and he is an expert on water and wastewater treatment technologies, urban solid waste management, environmental assessment, modeling, GIS application for environment, and so on. I mean, there's a long list of his expertise. I'm only giving a few, but the key point is he is a well-known figure. He is a serious worker, and he will bring his insight into the technological options for managing the food waste. Professor Dixit, all to you now. You may have about, I think, Deepika, how much?
Sulistyono dan juga para narasumber kita pada siang hari ini. Kami
15
juga
minutes.
ada Profesor Sulistyono.
Yeah, there is some problem in the
So yeah,
voice.
25 minutes, sir.
Yeah, 25 minutes,
Yeah.
please. Professor Dixit, all over to you.
Okay. Okay, so as already have been informed that I'll be talking about the food waste and its management, and particularly from the viewpoint of technology. Next, please.
Yeah.
Okay. So I think food waste, of course, is known to everyone. This is not a new thing. We all are wasting food, whether we like it or not. And you'll be surprised to know that a huge amount of waste, about 1.6 billion tons of food waste, is being wasted annually. And out of that, 50% ends up in landfill, and remaining only maybe something is being done, or it is rotting to the nature. This is actually very high figure because this is responsible for about 8% of the contribution to the global greenhouse gas emissions. If we were able to properly manage this food waste, then we will be able to achieve our sustainable goal number 12, where we want to ensure sustainable consumption and production patterns. And of course, we need to manage it efficiently so that we can reduce the adverse effects like greenhouse gas. Then a lot of odor is associated with food waste. You know, the normal sources of food waste are agricultural, fields, restaurants, grocery stores, and also the industry. But here the households are not listed, but they are the major contributor. If we talk about food waste in India, out of this 1.6 billion tons, about 68 million tons of food waste is generated in Indian cities or Indian homes, which amounts to about 50 kg per person per year. Actually, as a matter of fact, 1/3 of all the food produced in India get lost. Only 2/3 is being used. So this is a very serious issue, even for India. Next, please. Next.
Wait, just.
Who is changing the PowerPoint? I'll give you.
So it's maybe something problem. The slide will be something issues. Okay.
It is okay. We just go forward.
Yeah,
Okay. Why should we care about the food waste? We should care about food waste because it affects all of us. You know, the food waste actually in our municipal solid waste, which is very important, and we pay for its management, about 30 to 40% is all food waste in our bin. And this will end up being in landfill and will contribute to the methane production. It will also responsible for loss of energy. If we are losing food, that means energy is also getting wasted because a lot of energy is used for raising the crops, for supply, harvesting, and everything. Resources are also lost because fresh water, fertilizers, they cost money. And also food waste will cause the pollution of the environment. Food waste has social impact, right? Food insecurity and social inequality. It has environmental impacts like greenhouse gas emissions, resource depletion, land degradation, etc., and economic impacts such as food cost increases because 1/3 we are losing in India, for example. Financial losses to the farmers are there, and of course, if somebody is using crop as a main profitability for so many grocers and shopping mall, etc., it will also mean loss to the profitability of them. Next. Now, actually, household waste. Household people waste the most. You'll be surprised to know that out of 5.3 billion tons of food which is available, about 70% of it is actually lost or it is waste. 931 million tons is just wasted. You can understand how much is the resource wastage. And if we talk about per person, it is 121 kgs per person per year on annual basis, on global basis. For country basis, number is given here. Now, you can see that the maximum amount on an average, 74 kgs, is lost due to the people. Food services contribute to 32 kgs and retail 15 kgs. You can see that there are 5 worse countries where the waste generation is higher than even this 121 kgs. And other countries is okay, but India is actually 50 kgs per person. Russia is the best, 33 kgs per year, per person. On an average, 13% of the food is lost in the supply chain, and 19% of the food is actually lost in the consumer end. So in developing countries, food waste occurs at the consumer end, while in the developing countries, the food wastage occurs in the supply chain. Actually, food loss in supply chain is the major problem still in countries which are developing, like India also. It is still a problem. And there, in the developed world, they don't care and much more waste is generated at the consumer. Next, please. Actually, if you see all these statistics, what you see that what is the amount of food which is being wasted today? It could have fed all the people who are currently requiring the food security. In fact, this is the picture that food waste is enormous. I'm not going to talk about that, but this is very alarming. Next, please. Now, this is the hierarchy of the framework for the food waste. See, if the waste is surplus, food is surplus, then there are 2 options. we can avoid the generation of food waste, and excess food could be distributed to the poor people. So it could be used for feeding to the human consumption if it is surplus. But we have to find the mechanism. And the other part is that if this food surplus is not fed properly on time for human consumption or picked up and distributed, then it is going to be in as a food waste after consumption, of course. And then we have avoidable and unavoidable fraction. And then there are options. So for avoidable food waste, we can go for converting the remaining food to feed to the animal. We can go for composting, we can go for anaerobic digestion, we can go for compound extraction, incineration, and if we have to unavoidably dispose of the waste, then it could be landfilled. Landfilling is not a good option. Open burning and open dump could be also done, or it is being done, whether you like it or not, but it should not be done. Next, please. Now, if we come to the technological options, my option 0 is the food reduction, food waste reduction, and food redistribution before it becomes waste. So what do you mean by reduction? Reduction means mostly in the food chain it happens, better storage and handling, portion control while it is being served in the restaurant, awareness campaign that people should take that much food which they can consume instead of leaving it on plate, improve processing by converting the surplus before it gets fed into dried, canned, or frozen products so it can be used. So this is the best option. Or if the food waste is to be surplus, then it has to be redistributed. There are some mechanisms like food banks and NGOs where some charities are there, they could be partnered. Digital platforms could connect the donors with the recipients. Policy incentive could be given for redistribution by government. So tax benefit could be there. Community fridges is the option where spaces are shared for the excess food and people can move in and pick up the food from this excess food, which is basically stored there for the people, and it is waste if it is not properly used on time. One day we have to throw if it is not consumed within the lifetime for remaining it eatable. Collaboration with farmers, of course, this is not very perfect, but still it can produce some edible products which can be redistributed. If we talk about the technological option, basically it is the basic premises is the resource recovery. We should get something out of it useful because our food waste is also was useful and it is supposed to be useful even when it is in wasted form. So composting is very common. Many places we get compost. I'll talk about that. Then second option, which is very popular, is anaerobic digestion or biomethanation, where biogas or bio-CNG is produced. Then incineration is also possible. Photocatalysis is possible. Hydrothermal carbonization is possible. Dark fermentation is getting developed. It is a very recent process. And then pyrolysis can happen. Please remember, out of these first two, composting and anaerobic digestion, and also to some extent incineration, all others are in infancy. They are being developed and basically their use for managing food waste is still in the initial stage. It is not being practiced, and also it is more effort and money, more economics. Economics has to be very great, and rich countries could adopt them because they have definitely advantages. But please remember, we should not run the technology for food waste. Food waste should be easy to manage. We should not invest huge amount of money. That should be our philosophy as far as developing world is concerned. And developing world is more as compared to the developing developed world can take care of their problems. They can go for best of the best technologies, but food waste should not be there. Actually, food waste should be zero or minimum. Whatever 17% is actually, it is the same for still in this 21st century. Go to next, please. Now I'm going to go about talking more about redistribution. So this is redistribution actually is one of the most attractive. In fact, I have named this as zero. If any food waste is there, then we should distribute it to the needy people. It should be used. So what UN 2030 agenda says that we should feed the vulnerable groups. How? Food waste which could become, which has the potential to become lost. We should collect it and then let it not wasted. 1.3 billion tons of food is lost. This could be used productively for feeding the needy people. And it is enough. Then we don't need. Only the money is to be spent for its proper redistribution. And redistribution is always problematic, but we can optimize it as we can see in the last bullet point. Actually, every site, it has been found that about 2,000 tons of waste food is being discarded. Now, if we can, it has the potential to redistribute and also reduce the loss. So our picture will become better. Redistribution avoids 170% of the impacts and also saves 1.9 kg of carbon dioxide equivalent for every kg of waste which is donated or redistributed. Redistribution will reduce the production related impacts. And if we can go for formal systems and logistic enhancement for efficiency, etc., then we can take care of both optimization. So actually, you can see that there is what potential is there for even for the leftover food also. Food which is wasted in the parties and weddings or any social event, that becomes surplus. So if you know surplus food is there, you can always distribute it. Food is wasted by guests on their plates, which eventually is dumped in the bins. So that is not a good thing to happen because this should be avoided somehow. And food is dumped in garbage cans. Whatever food they cannot sell by the restaurant, hotel, etc., ends up in being they don't want and they have no willingness to give it to the needy people because they have another thinking that if they distribute to poor will make the line in front of their restaurant and which may reduce their being the exclusive restaurant and things like that. So excess food could be reprocessed and could be made suitable for feeding the animals. It can also be preserved, means you can keep in the community bin, community fridge system and refrigeration, and it could be served then and there to the people or next day to the homeless people. And of course, there is a need to change that you should take as much on your plate as you should and also eat less. Eating less causes less problem. Also health-wise also. Go to next, please. These are some of the strategies for food donors, etc. Since I don't work in this area, I would be skipping it. Go to next, please. But there is a role for everyone who can do good. Now let's talk about the most commonly adopted option for food waste management. It is composting. So composting is basically it is a process by which the food waste is converted into a type of humus and nutrient rich, which it is organic. So we take the help of aerobic microbes under the controlled condition. And controlled condition means mesophilic, 20 to 40 degrees, where the breakdown of simple sugar and protein in the food waste takes place. And then 40 to 70, which is thermophilic range, will also help degrade cellulose, fats, and it will also kill the pathogens. And then maturization process is there where it becomes becomes stable. Please remember, composting is also, you cannot leave alone. There are design factors like C/N ratio, oxygen requirement, moisture requirement, temperature requirement, like you have seen 20 to 70 degrees, and also particle size. Particle size should be fine, 1 inch to 3 inch, not more than that. And these are to be controlled properly, and pH also. If it is properly maintained, then end product will become a dark, stable, nutrient-rich compost, which could be used for the soil improvement. Okay, go to next, please. These are different processes by which at community scale, things could be done. Composting can also be done on individual basis also with the help of composters, which are readily available, more than hundreds and thousands type of vessel-based horizontal or vertical composting machines are available in the market, but they are good for only one family or 10 family or one building and things like that. But these are the static pile, solar assisted composting, mechanical and vermicomposting could be implemented on large scale for the community or city level, etc. Go to next, please. Now, this is the one which have been developed at IT. This is meant for four family setup, means 4 families living in one floor of the community. The type of multi-story building we have typically has 4 families in a one floor. So it could be shared in each floor. One of these set could be there. It takes only 2 feet by 2 feet space on floor and vertical. So the liability for the space is not much. So we designed it with the 3 identical plastic drums of 70-liter capacity connected with one common shaft, and inside the common shaft we have the mixing device. Blades are there which will mix. Okay, and one window is there in each of these containers for feeding the waste, and 2 windows are there on the opposite side to collect and empty the compost. And we have a 0.5 HP electric motor of 30 RPM, which is there, which will rotate the shaft. Idea is to rotate shaft only for 5 to 5 minutes each time a waste is placed. Next, please. Next. So these are some of the details of the system. These are the technical. We have named this system as Dutch home composter, and technical details are here. Go to next, please. This is how we mounted it in the terrace of our building because while the experiments were being done. So whole setup is here. Go to next, please. Now, how it is working, we start with the drum A, which is enough for feeding 1 to 15 days for the waste of the, so waste is prepared and then it is augmented with 5 to 15% of the leaves, and then this is fed for next 15 days. Every time when we feed, we are going to operate the motor for anti-clockwise and clockwise 5 minutes each. After 15 days, when it becomes full, we go to next B. So 16 days onwards to 30 days of feeding will be B, and then C will be up to next 15 days. By this time, the first one will get mature. We can remove it and empty it and use it after post-processing. The waste is ready for consumption in the society, garden, etc. Next, please. Another technology which have been developed and matured at IT Bombay is biostabilized aerated static piles, BASP. So this is a patented technology which we have developed. And here you can see that we have pipes are perforated through which the air is pumped into this with the help of blower. And then the prepared waste, which is containing food waste or any waste or municipal solid waste, whatever is there, it is made like a heap as it is shown in the middle. This waste heap is made, and then we cover with the some cover material or with the compost of the previous batch. Now what you can see that the blue arrows are showing the air, which we are going to apply maybe half an hour, every 5 minutes for every half an hour and thing like that. So we are going to put air every half an hour for 5 minutes or every 1 hour then we do every 2 hours after 7 days and so on. Within 1 month, the waste will be becoming prepared, and this waste will look like compost. We have to screen it and make it ready as a compost. Now, this process doesn't give the problem of mosquitoes and also odor, etc., because it is perfectly controlled. So this is what we are marketing. Go to next, please. One such system which we designed for one municipality, these are the actual pictures from the site. If you see the table, all the specification has been given about the preparation of these static piles. So we provided them consultancy. It is quite popular, but you can do at the scale of community, and you can do at every one or two house also. It is very, very possible. Go to next, please. Now, this is the second process, which is called anaerobic digestion process or biomethanation process. And here what we do, any waste can be converted, particularly the food waste, can be converted to biogas with the help of anaerobic microorganisms. And this biogas should contain minimum 40% methane, and remaining 60% methane, and 40% will be carbon dioxide, which we want to remove it by scrubbing through NaOH or any other. Now, this is also very controlled. It is done in a reactor, as you can see in the figure. You see that there are lots of feeds which are possible. Animal manure and everything is possible. Lots of choices are there for the feedstock, municipal solid waste and any crop residue, etc. Now it goes through the anaerobic digester. You can see these round sinks, and then gas is formed. Now this gas could be purified and it can be bottled or used in the bulk by the industry itself. So here also a lot of controls are required, like pH, temperature, C/N ratio, and microbes in the system. Many times we synthetically make the feed of anaerobes, which will be feeding along with the micronutrients like metal, etc. Go to next, please. Anaerobic digestion, if we go inside the process, it is basically a very complex process chemically and thermodynamically involving hydrolysis, acidogenesis, acetogenesis, and methanogenesis. As I've told to you, food waste can also be added along with so many other things also. Sewage sludge could be added, agricultural waste from the field could be added from farmers, organic fraction of MSW from municipality could be added, and it could be fermented. Here again, you can see that biodigester is there. Food waste is brought by the trucks. It is filled inside the anaerobic digester. Biogas is formed. And from biogas, we remove carbon dioxide and we make biomethane. And this biomethane could be used either in bulk and whatever is remaining as a digestate is used. Water portion is also used, and the organic fraction, solid fraction is also used as a fertilizer, and it is sold also. So gas is, of course, the main thing. It will produce on an average 250 to 400 liters of methane for every kg of the total solid. In fact, it is possible to also pre-treat the waste before it is fed to anaerobic digester through mechanical shredding and cutting, etc. Or chemically, we can do acidic and alkaline treatment. Biological treatment could be done with the help of inoculating with bacteria and fungus. And even the ultrasonic and ultraviolet type of treatment also have been found to help the process of increasing the output of methane, which we want ultimately. Go to next, please. Now, this is the process I will not go through. This is those people who want to go through the biology and the enzymatic breakdown and optimizing them can go through. Go to next, please. There are different kinds of anaerobic biomethanation plants are available. These are the reactors only, and then we need accessories. So first is CSTR, completely stirred tank reactor. Everything is well mixed. As you can see that there are rotors which will ensure. There is USB, anaerobic sludge banket reactor, then anaerobic baffle reactor, and then we have fluidized bed reactor. All of them has some advantages and some disadvantages, and you can choose whatever one you like the most. Go to next, please. Here, and this is the full process, some 5-step process for a typical plant. So bioreactor is only one part, but how to receive the waste, and then how to prepare it through shredder machine, etc., and then make pulp out of it by adding the leachate, etc., or water, then feeding into the reactor, and then purification of the gas, and also collection of the liquid portion, and also the bottom portion is also fertilizer. And then after purification, it could be sold as a fueling station, or it could be bottled bulk distribution for individual use or for bulk use in the industry, etc. So it is a very promising technology, which is very popularized in the developed world. Go to next, please. This is a very one technology which we are developing, and we have developed to some extent, high solid biogas generator, which we have developed. As you can see, this is based on backfills. So backfills are there. So retention time is very high. So this is the elevation inside cut portion, and biogas is generated at the top, and whatever waste is digested can be removed on frequent intervals, and then it is continuously being fed at a rate every day. Go to next, please. This is the plant. So many chambers are there actually because of the baffles. And then this is just for those people who want to understand something more about its layout, etc. Go to next, please. Now, this is dark fermentation process is actually recently it is developing. So these are still under research, whatever I'm going to talk. Dark fermentation, basically, what it does, it converts food waste into hydrogen. And dark means we don't require to use, actually sunlight is not required, not desired also, in diffused form also. So we have to ensure that we wrap it into properly and insulate it so that it will not happen. And this hydrogen is produced, and along with that, many value-added products could also be produced based on our control, acetate and butyrate, etc. So definitely it is very good. And you can see that basically we can do the reactor before preparing biomass. Biomass could also be pre-treated with the physical, chemical, biological type of controls, etc. And the reactor, dark fermentation reactor, basically has controls are there, pH, and these we have to optimize by doing experiments. Yes.
Professor Dixit, sorry for intervening. Can you wind up in 1 or 2 minutes, if you don't mind?
Yeah, I am no problem.
Okay, thank you so much.
Okay, actually I prepared for 45 minutes because
okay.
Not for 25 minutes, that's fine. Okay, anyway, I will just
No, thank you.
get the essence. Okay, go to next, please. These are various reactors for dark fermentation, and it is still not mature. It is still being marketed also, but there are some things which are to be evolved. Go to next, please. Then next process is photofermentation. Photofermentation, as the name suggests, it is again hydrogen production, but we have to use purple bacteria and light driven. Light has to be there. So we have to provide light source, either solar light or some artificial light. So we can use a lot of solid waste as the fuel, and it is very good for the sustainable hydrogen economy, which we are talking about, is actually based on that. We are thinking about that. So, okay, go to next, please. This is photocatalysis process, and here what we are doing, we are going to use light activated. So again, light is required because photo is there, and catalysis means we need titanium oxide type of catalyst for organic degradation. And basically, because UV rays are there in our visible range, will generate the hydroxyls, and that will cause the lysis, hydrolysis, and everything, degradation of organic and food waste. And what we generate are the things which are useful. Okay, we can get again it is more being used for the wastewater rather than being used for the solid waste, but we can use it after modification. Go to next, please. I'm skimming this. Go to next. I'm not going to talk about this, where we are seeing this is hydrothermal carbonization, HTC. This process is actually showing the promise where the wet biomass is basically converted into hydrochar. But the temperature requirement is 180, about 200 to 300 degrees, and the pressure requirement is 10 to 50 bar. So you can understand that the reactor has to be very strong. It should withstand 50 atmospheres, and temperature has to be very high. So the cost of reactor is going to be very high. You can see that a lot of feedstock could be used. Anything which is organic in nature could be digested here. And it's basically, this is going to mimic the coal formation in nature. But the whole process doesn't take years or hundreds of years as it is in the geological cycle of Earth. Here we do in few hours itself. So what is happening? We feed the slurry, and afterwards, whatever we get slurry, we have to separate through liquid and solid. Liquid portion is nutrient-rich liquid byproduct, which we can use for the fertilizer, and the solid fraction after drying will become hydrochar. And this hydrochar is just like coal substitute. Go to next, please. Go to next, please. Incineration. Incineration means burning, combustion. So basically, idea is to burn or incinerate the food waste. So food waste has to be mostly dry. So dry waste, food waste could be taken, and then it is burned into the furnace, and then steam is formed, and this steam will turn the turbine, and then the generator will produce the electricity. And whatever is the flue gas coming, that has to be treated before it is discharged into the atmosphere. Whatever is the ash is actually, it has to be used for commercial purposes, or it has to be disposed of. Okay, so food waste is not proper because the way it is very, very wet. So we have to dry it before feeding to it. The next process is pyrolysis. Pyrolysis is nothing but the solid refining process, just like oil. So when we heat it into a chamber or pyrolytic chamber, gas is produced, which is called syngas, which is mainly hydrogen and carbon monoxide, methane, and about 50%, 60% is carbon dioxide also. So we produce syngas, we produce bioliquid, which is coming at the end of this particular yellow pot, if you see, tank, it is bio oil. And then we have whatever remains within the chamber is biochar. So we have three components: gas, liquid, and all are fuel. Pyrolysis is a costly affair, but it can be completely closed and very useful for future when we don't have coal and all those kind of, we run out petrol and diesel, then it may be the only source. Go to next, please. Go to next, please. So this is some comparison, which I'm not going to talk about. What is the temperature requirement, etc. Pyrolysis temperature is very, very high, you can see. 300 to 700 and no oxygen. Incineration is 850 to 1100 because fire has to be there, and oxygen requirement is 600 to 700 times, or minimum 300 times more than the stoichiometric requirement. And HTC actually is moderate, but the problem is not temperature, but the temperature pressure. Pressure has to be 10 to 50, and everything has to be fed as a wet condition. Go to next, please. This is how we can integrate the technology options actually. This is one suggested here. This is one suggestion. One, integrated waste management, where we are using anaerobic digestion as the first, followed by hydrothermal carbonation, and then photocatalysis, etc. And we have to integrate into society. It is like a closed ecological model. Go to next, please. This is the food processing and associated CHG emissions for when you want to plan that how much you are going to be effective if you divert these kind of activities, the food waste generated from there, all these activities, harvesting and all those. So this is just for your guidance. Go to next, please. This is the summary. So you can, everything has been summarized here. What are different options where food waste is in the center? What different things you could do? Everything is here. Okay. So I'm again, what type of things you can get out of food waste is also given in the next figure. Okay. So it is a lot of resources are possible. These are some of the India-specific policies which are being used in India presently for waste reduction and redistribution. Not necessarily that they are meant for that, but they are leading to the food reduction and redistribution. You can go through it, and if you have any question, you can call me back. And then next slide, I'm giving, next please. This is the waste to energy conversion policies in India. So they may not be valid in other countries also. So these are some of the schemes which have been floated by the government. So in case you want to make the, like National Green Hydrogen Mission is there, where dark fermentation and gasification to hydrogen will qualify to be it. But there are other schemes also like biofuel policy and all those can be used if you want to make the use of these for converting food waste and also get the help from the government of India. Okay, so go to next, please. So this is all I want to talk. This is based on these references. So any questions?
Yeah, thank you so much, Professor Dixit, for such a rich presentation. Lot of information and lot of technological innovations you presented from from recycling to decomposting to anaerobic digestion to redistribution to pyrolysis to so much. I think you gave a plethora of possibilities of how we can manage the waste. And I think we are really enlightened by your presentation. We don't have time for question and answer right now.
Okay.
Maybe after the next panelist intervention, we will see how much time is left. And if
Sure.
everyone agrees, we may extend our community of practice session by 15 minutes so that we take most of the questions. Thank you once again, Professor Anil Dixit. Thank you so
Thank you.
much.
Thank you.
Okay, now I have the pleasure to invite Ms. Annie Adila Kamaruddin. She is a Deputy Director of International Networking Program in the Corporate Communications Center from Malaysia Agricultural Research and Development Institute, MARDI. Now, about Ms. Annie Adila, she has been representing MARDI in APARI and especially in our governance meetings of executive committee and all, she has been a very active player with APARI and has supported APARI quite a lot. If you look at her professional experience, she started her career 25 years roughly ago as a science educator at a school somewhere in Malaysia. And from there, finally, she became a director of corporate communication. And eventually, now, with all the background, she is working as a deputy director, international networking program. And she is leading a FAO project on My Save Food initiative. Now, this My Save Food initiative actually is a program which brings education and awareness. Now, from technology, we are going to education and awareness. Nationwide, what they have done with the corporates and with all the stakeholders, which a lot of awareness program which she is going to highlight. But the key point is this My Save Food at Ramadan initiative is what is her key contribution in this area of food loss and wastage. Miss Annie Adila, over to you. And kindly keep it for 15 minutes if you don't mind.
Okay, great. Thank you so much, Dr. Ravi, for the introduction. Hello, everyone. My name is Ani Adila. You can call me Ani. And as Dr. Ravi mentioned, I'm in charge on the My Safe Food initiative, which originally from FAO. The original program is a Safe Food initiative, but for to implement this program to Malaysia, so we changed the name to we put an additional MY at the front that means Malaysia. So is this campaign is this initiative is already start 2016, almost 9 years ago, but at first we a bit struggle to create the awareness to promote the public to not waste their food, because I think 10 years ago we believe our public in Malaysia, they just don't believe the effect of increasing food waste. But after a while, we continuously promote this campaign to the public. Every year we have collaboration with private sector and NGOs and other government agencies. We managed to increase the public awareness, and one of the program that has successfully we do is My Safe Food at Ramadan. As maybe I just introduce you a bit about Ramadan. Ramadan is a month where a Muslim do the fasting for 30 days before celebrate the Eid al-Fitri. So in Malaysia, Ramadan month is like it's like a food party, I can say, because when we have to fast from like 6 a.m. in the morning, and we can breakfast at like 7 p.m. approximately, and then when we didn't eat for one full day, when we for preparation for breakfast, every what can I say, every house area, they have a food market. It's already cooked food market. So the problem here we see every time there is always unsold food by the food seller. The food market here we call Bazaar Ramadan. Everyone didn't see the problem at first, but when we start this campaign, we saw there is one person at Kuala Lumpur. He standing in the middle of the bazaar, making his own initiative to reduce food waste. From that guy, we start to bring him to our initiative, and we make it like a national campaign. And nowadays, it become a national campaign, which is supported by our ministry and also another ministry as well. So this Bazaar Ramadan is already support like 3 ministry at the moment, and led by Mardi and supporting by other government agency as well. Bazaar Ramadan, the main issue here is when the food seller cannot finish to sell their food, and the food is already cooked and is not really suitable for frozen, or it when the food is already it's easily rotten, and then it must be taken in for a few hours after the breakfast. Let's say we breakfast at 7, the food must be taken by the consumer by 10 o'clock. As simple as that. So Dr. Dishik just now already mentioned about how to reduce the leftover. Even though we try to promote people to eat less, but in Ramadan month, when you are fasting for the past 10 to 12 hours, you tend to buy more from what you can eat actually. So this is where My Safe Food at Ramadan come, where we collaborate with NGO and 1,000 of volunteers all over Malaysia, and we collect unsold food from Bazaar Ramadan, and we distribute to the poor family around the Bazaar Ramadan house area. So in recent Ramadan months this year, we have 200 bazaar that willing to take part in this initiative. If to compare 10 years ago, we only have 2 bazaar when we start on 2016. So the total we can collect this year, which is we save the food from being waste, around 70,000 kilograms, and we managed to distribute to the poor family before it become rotten. The place that we also distribute is not only for the house, we also distribute to the homeless housing area, and also the mosque, and also at the university. Somehow this project can save a lot of unsold food from bazaar, and we see here how we want to save the food is not only to using the technology or support from the government, but it's also NGO play a main role in reducing the food waste, because without the NGO, I think this kind of campaign we couldn't do it with our own team, because for my team I only have 3 people working this initiative, but with the NGO we can work this initiative with 200 bazaar and we manage around 3,000 to 4,000 volunteers in 1 month. So it is indeed nowadays considered a successful program. The government also asking us whether we can do this program to the wet market, but there is something that we have to look into it. Other than that, I think that's all I can share right now, Dr. Ravi.
Thank you. Thank you so much, Ms. Annie, and also for being very succinct and very brief. And I think you highlighted very well how a case study of a Ramadan initiative to avoid the food waste, and where you can involve the various stakeholders like NGOs and many other players. And that is an example actually, which, because there are, like Ramadan, there may be many other festivals and opportunities or occasions where there might be food, maybe a central subject, and how we can really work to avoid the waste. Thank you, Ms. Annie. Well, friends, we have had two presentations, one on the technological innovations and one on how to save food by using a social perspective of it and distribute to the poor people. Now, uh, we will extend the co-op session for 10 to 15 minutes, and we will invite questions, if any, from, I see in the chat box, there are a couple of questions, and I would like those who have given in the chat box, if they can raise their hand and ask a question by themselves. And one question, Mr. Dixit, Professor Dixit, for you is, which I find is very important, is about the public-private partnership in managing food waste. It is from Mekong Organics, who are doing a project of ACIR in the region.
Okay.
Yeah. Yeah, go ahead, Professor Dixit.
No, I am not aware of this partnership. I'm not
Okay.
part of this also.
Okay, thank you. Any other question? Anyone who would like to ask question by themselves, or should we pick up from the chat?
I want to ask one question to Professor Dixit. Is excellent talk, Professor Dixit. I got gone back to 8 years AIT association. You know, food, we are converting food to energy. Most of the examples that you cited, why not directly food is converted into aqua feed, fish and prawn feed? Because I know one company doing the big business, they collect the food, they sterilize the food directly, and then make some amendments like vitamins, some deficiency components they add, and make granules and pellets and supply to different. This was in Hong Kong, I have seen this company, but that is more profitable directly, food to food conversion, but with some chemical engineering and so on.
Okay.
What is your expert opinion on that?
Actually, we work at the last end of the pipe when everything is thrown.
Okay.
Nothing is it is declared as a waste, and then we try to recover something out of it. What you are telling, before it gets rotten up,
Yes,
it has to be used for feeding purposes of animal or fish or aquaculture purpose, etc., or other life form. So it will be very good.
That is also, say for example, if you have IIT's 200 kilograms of fresh food, that is food prepared in the morning, if they throw after 4 p.m., that can be straight away converted into animal feed.
Yeah. That they're doing feeding to the cows and buffaloes and
this one is straight away to fish and aquatic organisms. Thank you. Nice hearing you. Nice seeing you. After
Thank you, Professor Prasad. Yeah, very nice. Yeah.
Excellent.
Thank you. Now we have a question from Mr. Olaivola Agoro.
Thank you very much, Prof. And I'm very happy with the presentation. I'm currently in Africa, sub-Saharan Africa, Nigeria to be precise.
Okay.
Before now, I tell you there used to be a lot of food waste. And you see foods be dumped in different places. And I just found out that now, possibly with the poverty situation, you find out that it's very difficult for you to see most of this food being wasted. I tell you, I visit restaurant to get waste food for my dogs. Initially, it was free. They give it free, but now it's becoming expensive. They sell it and it's becoming very expensive now. So my question is, I looked at the technology, the bio-stabilized rated static pool, and I'm worried when you feed, prior to your feeding the food waste, do you do sorting? Do you sort? Because apparently food waste comes with different components. Are you supposed to do any form of sorting before feeding the waste, or you just feed directly? Thank you.
Of course, I could not understand your question properly. I see most of the time when you feed food waste, normally, food waste is already containing water. But only one type of feed is not enough. So we will also be using other, like the municipal solid waste, that we have to make pulp using the water or some other source of water, etc., or water substitute. And then we can only feed. Solid things are normally not appropriate to be fed in most of the reactors, etc., except composting. Composting solid thing could be mixed directly also. I hope that this answers your question or your.
Yeah, yes, it does. Because I was looking at the solid ones. Then I'm equally worried because this technology is actually meant for household. How do you eradicate the odor? Because there will be some odor that probably come out of it.
None of these technologies are meant for household, except few. Many are meant only for the community scale. See, when we want any technology to be like, nobody will go for anaerobic digester in their home. It is very costly. Nobody can afford it. Not less than 30 lakhs for even a small model of say 4 kg per day type of food waste. Not possible. So only municipalities with the 300 crore project may be able to actually afford it. Okay. So household things is only composting, where you buy some sort of device like I have told you that three-stage composter, which we are marketing. That could be. And there are so many models available. Everyone is saying their machine is better than ours or everything else, something like that. So you have to only use those. Their nuisance for that odor is not that much because everything is enclosed normally.
Thank you.
Thank you very much, Prof.
Yeah.
Thank you.
Now we move on to, we have two more hands raised and some question in the chat. We'll start with Dr. Riga Shibli, who is also a close friend of Apari, and we work quite closely. Dr. Riga, over to you.
Thank you, Ravi, and thank you for organizing this webinar. This is really an excellent subject, and I think every country in the world need to do a lot in this direction. It's just a matter of when I look at Dr. Dixit presentation, well, it's really an excellent to move to the technology and to get these things. But when I'm talking about a large scale, when you get a large scale plant to do the work, I mean, what is the possible way to collect this food waste? Because usually the problem is mixed with a lot of other things sometimes. So you have to categorize it, to have to find a possible way to collect. And then, because if you are dealing with a large scale business, I mean, you have to get a inputs for the work. So what's your vision in this direction, actually?
See, when we get the waste from waste or whatever material feed stock from multiple sources, we have to receive it at central place. Then we have to do sorting and removal of the things which are not desirable. We have to pick either by hand on a conveyor belt, or we have to do with the help of machines. Most of the time, size reduction using shredder or any other mixing device or size reduction device is very much required. So these are the pre-treatment which you have to do before you can do any technology, including composting, etc. also. So this is prerequisite
Thank you.
normally. Yeah.
Thank you.
Thank you.
Yeah. May I move on to Dr. M.K. Nayak now? You're on mute.
So, good afternoon, and I congratulate Professor Dixit for a wonderful presentation, very informative.
Thank you.
One duality, rather dilemma. See, for example, in a country like India, when we talk so much about green energy, but at the same time, we are scared to spare our food commodities like sugarcane or sorghum or maize, particularly for bioenergy, biofuel production. But when I saw your statistics, almost 1.8 billion tons, I don't know how much India will contribute in that 1.8 billion tons, quite a lot, almost contributing for 8% of the greenhouse gases. So in a way, we have already seized that opportunity of food insecurity by food waste, man, and how best we can really, knowingly or unknowingly, whatever is wasted could have been brought into the green energy fold. But that is not visible in at least in our country, especially in rural infrastructure. How do you visualize to change such setup for Indian condition?
Of course, see, I know about Food Corporation of India, for example. This is one organization which was set up in the India to ensure the security of food and to feed it through public distribution system. So they have huge warehouses where huge amount of crops are procured at MSP, which is also a problematic area in India. Everyone wants that everything should be purchased by them, government, and there should be bare minimum. So I'm not going into nitty-gritty and politics of these things. Many states are very active in this politics, but I'm talking from technological viewpoint that Food Corporation of India inherently has the problem of inefficiency. Though food is there, they are not managing well. Many times they are not storing well, and lots of things are diverted illegally, and all those things are also happening. Actually, India's biggest problem is the loss in the food chain, not in at the production. Production is good. Marketing is not good because this is the efficiency is being stored here. So government has introduced one instrument called public distribution system, which is actually not in very good form nowadays, but it is at the time of it was revived very good at the time of COVID, that everyone was fed because of we had almost all control over at the government level. Otherwise, if we keep the things to market, I don't know how well that will be happening. I don't know, because I am not the domain expert. I'm basically engineer, and also that too also waste management. When everything is lost, then things come to me. Like a doctor, we do surgery.
Thank you, Dr. Dixit.
I understand the problem, but as Food Corporation of India is the biggest agency handling the food commodities, whether we can legally have some percentage of food commodities exclusively meant for energy security, or whether you want to manage after food is going to be wasted after preparation. How do you take it? That was my this one, because otherwise we have been already losing, whether you like it or not, which we do not want to lose it, but we have been losing.
Yeah,
No,
actually, India is also a country which is struggling to label it as a democratic or socially controlled. We don't know. So I don't know. I don't know the answer to this. Of course, it will be good to some percentage should be diverted towards the energy security also, in my view. Because
I think that is a very, very important discussion, and it requires a bit of political flavor at some stage and some discussion. But we'll confine to our technology and our ways of making awareness on food loss and waste. Yeah, I will just go for the last question and then we close. Mr. Nasaya Kairam, over to you.
Yeah, good afternoon to all, and congratulations to Dr. Dikshit and Anedil for the excellent dispositions. One point I would like to add is like we have many these things for waste handling. Technologies are available. Many people are bringing these technologies to the table, but they are not going or widespread in the field. So that is how we can make it more cost effective or more user friendly, so that we can take it to
certain problem with his microphone, but I can
yeah.
hear. Yeah,
Are you able to hear me, sir?
yeah. Now, yes.
Yeah. So the other thing is like in other presentation, the behavioral change. So like we want to reduce the waste. So how we can harness AI or social media and ICT to amplify these messages like prevention of food loss and waste. So maybe IITs and these people can try those all, how we can effectively amplify these messages to especially Gen Z or next generation kids, so that they are aware. But these will be very effective. Like if the new generation is made aware of, they can play a good role. So that is one thing. And the regarding this Food Corporation of India, CIFET has done in 2016 the last norms for storage of these grains, the loss of food grains technologically, what should be done and what is the percentage of losses, and with good management practices, how they can be prevented. So now the SCOG report has mentioned that because of adoption of those one country, one norm, like all FCI godowns or warehouses adopting our norms, they are saving around 6,000 crores per 600 crores per annum, compared to 400 crores loss around 10 years back. So around 1,000 crores at conservative estimates, they're annually saving. That COG report is saying, by adopting our scientifically done norms for national level storage of food grains and other things in warehouses of FCI. This is what I wanted to say.
Thank you so much, Mr. Nasaiya Kairam, and I think you will be one of our speakers. I see you have a lot of points to move forward, and especially from the public sector angle and awareness program. But thank you so much. And I just have a quick question for Ms. Annie Aguila about if you have any example of scaling up of your My Save Food at Ramadan initiative. Was it only confined to your region or your country, or did you see scaling up by the FAO?
Yeah, at the moment, we don't have any plan to scaling up to other country because this is specifically on the Bazaar Ramadan, and different country has a different kind of food. If we want to scaling up, we have to study on the food, on the receptive of the unsold food, and there is a lot of things. But currently, we don't have any chance to do that at the moment. But
Thank you.
can I answer Mr. Kairam question just now about the behavioral change for the Gen Z? Just 1 minute, Dr.
Yeah,
Ravi.
please.
It just we are from My Safe Food Initiative, we focusing on creating awareness through social media, and also even though we do a lot on the social media campaign, we provide a video and interactive short short poster, very interactive poster for awareness. But however, we think that the most important is awareness at school. Awareness at school is very important because that's where our younger generation learn about how to produce food and how they have to appreciate food. In My Safe Food Initiative, we also have a good campaign. We collaboration with Tesco. Previously, we promote like almost 1,500 students from 20 schools all over Malaysia. So this is a very good program. I think this is something that we can look into and we can share with other countries. Thank you.
Thank you so much for this additional insight, Ms. Annie. Okay, friends, we will be.
Just quickly, can I come in about this adopting? Like now we have Durga Puja, this thing in India. If they can, if your country has a representative in India, can we have for unlimited scale for Durga Puja? You can consider taking the template of Ramadan and seeing that if it can be replicated in West Bengal or maybe for the timing. That is quick suggestion. Thank you.
Yeah, no, that's an important point, Ms. Annie. I think you may communicate with Mr. Narsaya Kairam on that to maybe share the report of your project, FAO project, to see how they can apply or adapt or adopt the same in another festivals elsewhere. That would be an example of scaling up again. Yeah, thank you. So, friends, I'm sorry the discussion is becoming very interesting, but we have to stop. We have taken 25 minutes more of all of you. Thank you so much for staying with us. And the key point which we can conclude from the whole webinar is I cannot sum up the rich information which has been provided, but I think what I'm concluding is if we really want the food security, we should not invest too much on the chemical, fertilizers, seed, technology, and all for producing more, because we are putting a heavy pressure on the planet, on the earth. If we can save, probably we can equally solve the food security problem. And food loss and waste management has been given some importance in the UN Food System Summit, but not as much as it should be given a push. And I'll give you one example from a Nature magazine, which was published a few years ago. For production side, if you can save 1%, only 1% of crop loss in the field globally, only 1%, you can feed 25 million people. The point is, if you can save 4%, you can feed 1 billion people. If 8%, 2 billion people, the number of people who are hungry in the world. The point is, where is the global focus? We have to be careful. These missions, these technologies have to come for food loss and wastage avoidance. They have to come forward. But there are a lot of things. There are companies, there are, like vested interest and so many things that people want to go for new technology only to produce more. And I think that technological innovations of management of food loss and waste with a very solid awareness and campaign kind of a program like was presented from Malaysia, I think these are the things we really need to think more and more as we move forward. With this, thank you, all of you. Thank you so much. Over to you, Deepika. You're on mute.
Mute.
Yeah.
You're speaking to yourself. Yeah.
I'm sorry, sir. And now we are close this session, and I would like to extend thanks to all our speakers, panelists, and participants, their active engagement. And sorry for that. If we are not involved the questions, you just write it. I will share the proceeding and PPT also. And a special thanks to our keynote speakers, Professor Rekha Dikshit, and our panelist, Annie, and for your valuable story, which is real story, and express gratitude to Dr. Ravi Khetrapal for his leadership and moderation of all the session. Thank you so much. Appreciate all the participants and their engagement, and see you next COP. Thank you so much. And thank you so much.
Yeah, and thank you, but please switch on your camera for your smiling photo we need.
We will take group pictures. So please open the... Thank you so much. See you our next COP.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.
Bye.
Bye.